Okay, I guess all of you can hear me. Also can see the slides. If yes, then please say yes.
Yeah,
Uh, so we are in the week 10 of problem solving sessions of Natural Language Processing course. This course is taken by Professor Pawan Goyal of Indian Institute of Technology. The course code is NOC 2022 CS98 and I am Punyajoy Saha, DOT chemistry. So this week we are going to like we are here. Earlier week we were focusing on LDA or like topic modeling, find out themes from the documents. This week we are focusing on another task, that is entity linking. So in brief, that this is a task of identifying all mentions in a text of a specific entity from a database entry. So the overall task is that you will be given a text, for example, a news article, for example, and from that news article, we have to find out all the entities which have a link in the database. For example, a news can be about some political event. So there can be like a mention of a place, a political party, or a political entity, and you have to refer it back to whichever this entity is. They'll be also present in the database, and you have to link it, like find which one of them are present in the database. And for this database, we from this database, like there are different databases that can be used, like Wikipedia, Yahoo, or Freebase. And there are two main phases. One is candidate selection, that is entity annotation. So before even starting the process, we have to find out which are the potential entities. So this again have like a machine learning backend. So you have to train a model to identify the entities, and then we have to do entity resolution. So in that case, we will try to find out which entity belongs to which entry in the database. So there are two steps, and so we are mostly talking about the when you're talking about entity links, there are two things that it needs to handle. First is name variations. So this has a question as well. So entities are referred to in many different ways. For example, I can say NY and New York. So both of these will be a way to refer New York on, but they are different in their naming conventions or entity ambiguity. So a simple thing can be like um, yeah. So uh, yeah, simple thing can be like entity ambiguity. If I say like bank, so it can refer to different entity, like River Bank or the bank as an institution. So this ambiguity remains here as well. Okay, so now after this brief introduction, let us move to the questions. So the first question is, which of the following phenomena can pose a challenge to the text task of entity linking? Here it is a multiple like correct answers question. Like you can have one more than one correct. So can you tell me, based on the introduction itself, you should be able to answer this. That uh, what are the phenomena that can pose a challenge to the task of entity linking?
Are all the above? All A, B, C, D?
A, B, C, D. Okay. Uh, okay. Can you okay, let us go one by one then. Any other options? Like any other selection of options? Sorry. Like, does anyone think any one of them is not a challenge or
So, for
D
example,
is not a challenge. Option D.
okay? Why do you think so?
If some attribute is entity is not in the database, it doesn't come into consideration. So
Yeah, correct. So let us go one by one then. So the first option is variations in textual representation of the same entity. So this can be like New York or New York. So one is a capital, first letter is capital, other is one is simple. So and you can also have like spelling errors or something like that. This represents the variations in the textual representation. Then there can be abbreviated names of the entity, as I was saying, like New York or NY. So this can be two ways to refer the same thing, but one is abbreviation. And then there can be multiple entities with the same name, like Paris. So Paris can be a capital of France, or Paris Hilton, who is an artist. So there can be multiple entities with the same name. So if you see at Paris, which one entities to link with is another challenge. But for missing attributes to the entities, we do not really bother because we want to connect to the entities. If their attributes are missing, it is a problem for sure because we do not know the properties of the entities. But it does not actually hamper the linking task. The linking task is separate from the related task. Like if you want to find that, okay, Paris, what are the different attributes of Paris as a capital? So this is different, but the linking task is solved already.
Okay, sir.
That is uh, that is not needed, right? But anyways, like it is a challenge, not particularly for this entity linking task. Okay. Okay. I think okay. Move forward. So in the task of Wikification, what is the order in which following steps are performed? So first of all, what is Wikification? Does anyone know what is Wikification? So it is like you can guess it also if you do not remember. And we have partially talked about it in the introductions.
Sir, linking it to the Wikipedia
Yeah.
article.
So when we are using, so when in the process of entity linking, we are using Wikipedia as a database of knowledge or knowledge base. Then that task becomes like task is called Wikification. It's just a fancy way of saying the same thing. But anyways, okay. Now, so what is the question here? So to do this entity linking, basically with Wikipedia, what are the steps that needs to be followed? And what is the order in which the following steps are performed? So first step is mention detection, entity disambiguation, and then link generation. So this will be again a very easy task, but tell me which is the correct option. First, think about what is the given doc. So let's say first is the document that is given. So what we need to do first in order to even start the entity linking process.
Option D is the correct
Option,
D.
yeah. First is mention detection. Then we have to disambiguate the entities. So we have to find out which entities mean which, like for example, the Paris example in the previous case. And then we have to finally create the link. So I think it's more or less simple. Yeah, then you have to create the link generation. So link is created from every entities to the candidate. So first is the mention detection, that is to find the linkable phrases. Then we select the entity links, that is we connect all the links, and then we finally disambiguate between different entities. Then the last step, I think that last step, the disambiguation. Okay. The third question is: can we? So there is there any doubt in this? Sir?
Can you elaborate mention detection?
Yeah. So mention detection is when we have the document itself. So let's say you are given a article or a news article. So now you have to find out. So it is a, let's say, a political article, for example. Now you have to find the phrases which can mean the entities. For example, there is a mention of Congress Party. That is one phrase which is the entity. Then there may be mention of Rahul Gandhi. That is another entity. So this part that we are identifying which entities can actually exist in Wikipedia, which words or phrases is actually existing in Wikipedia. That process is known as mention detection. So usually what happens is you can by like train I think a machine learning model to identify these mentions, like which one of them are mentions or not. So that you can do. But that is the first step.
Okay, thank you.
Okay, let us move forward. Yeah. So the question is accurate mention detection and disambiguation system using. The question is asking if it is possible to do mention detection and disambiguation using keyphraseness and commonness. If no, why? So what is keyphraseness and what is commonness? Yeah, so this mention detection can be done using this process known as keyphraseness. So does anyone know what is this? So keyphraseness is a number of Wikipedia articles that uses this word as an anchor divided by the number of articles that mention it at all. Yeah, so I think it will be clear if I show the form. Yeah, so this is the formula. So collection frequency, the term W as a link to another Wikipedia article. So in Wikipedia, you might have seen that there are different entities which link to other articles in the other articles uh, in Wikipedia. So we will try to find out how many terms, how many Wikipedia articles are like that, where W is an anchor. So that is W is a link to another Wikipedia article by the total number of times W appears. That is the collection frequency. The collection frequency where W acts as link versus the total collection frequency. So that is key phrase and commonness. Yeah. Commonness is shown by this formula. So commonness means that given a sense or a type of link, what is the number of type of sense? For example, bank versus river bank versus the bank as an institution. So how many times bank as an institution appears of that particular sense by total number of links or total number of occurrences. These are the two things that we use for mention detection. Mention detection and then disambiguation. So based on this, let us try to answer this question. So first is, will this be accurate? So here accurate by accurate means both the systems. So if both the systems will be
Excuse
accurate.
me.
Yep.
Can you zoom in the slide? It's not clearly visible.
Okay.
Okay, thank you.
Yeah. So accurate here by accurate we mean both the mention detection and the disambiguation system will be accurate or not. And if not, why? So first we have to decide if it is accurate or not. So what will this commonness do? So forget about this like the key phraseness for now. That let's say that is working correctly. So what will this commonness do? It will take all the frequencies of different senses and then try to find the most. So the and try to like have the numerator as a one of the senses, and we will select the sensor which is the highest value. So highest value means that whichever has the highest value on the numerator. So let's say there are 5 senses of a particular word W. So we will select that sense or that particular link which has the which is the most frequent. So that is the second option, the B. So that means whatever be the correct sense, we will not be able to find that sense every time. Like whatever the correct concept in that particular entity is, we may not find it every time because of our formulation, because it will always select the frequent one. So the first option is no, so it will not be accurate. And the reason is this, that commonness will always select the most frequent concept. So that is also like you can understand from the term itself, like it is selecting the most common thing. And so, and what is the most main problem here? Why selecting the most frequent concept is not right? Because the commonness does not take context into consideration. So, for example, the bank example, if I have the concept that uh, I went by the river bank, so if I have that concept that there is river and uh, I went by, so that river part is actually the context. So that thing is never taken into consideration by the commonness method. If I take that context into consideration, I will be able to understand the concept of the entity method. So these are the two options that are the correct answer. So first is it will not be accurate because it selects the most frequent concept, and it by selecting the most frequent concept, it does not take into account the context that is used for entity disambiguation. Did you get my point?
Yes, sir. So, what about key phraseness?
So the key phraseness is, I guess, it will be more or less correct. So because it does not depend on the context as such. Because if we find a link to a different Wikipedia article, that means that entity is there. So if the link is not there, means it may be something very common, like a verb or an article AN or something. But if there is a link, then we are more or less sure that it will be an entity. The key phraseness is actually more or less correct in these cases. Any other doubts? Okay. So these are the correct options. Then we move to the next. So the text span S is equal to Tokyo occurs in 500 different Wikipedia articles. Calculate the key phraseness of Tokyo. So if we go a little back, so we have the key phraseness uh, formula. So that we have to apply. So what we are given that there are for concept 1 there are 316 cases, concept 2 110, concept 3 10, concept 4 7, and no link 57. Okay, so there's 57 articles. We do not have a uh, there is no link where this Tokyo is mentioned. So what we have to do? So let us write the formula. So this is the formula for the yeah. So what we should do next? So let us try to calculate this. So you have to find C of WL. So wherever W is a link, we have to take that into consideration. So there are 4 cases where W is in link. So what we can do is so C1 plus C2. So I am representing this CF by C1 C2. So I think it is C4 and divided by the total number of times it is appearing, that is 500, that is given to us. So now calculate this value and tell me the answer. What will be the answer?
0.886.
So, yeah, so basically this. So we have 316 plus 110 plus 10 plus 7 and by 500. So 443 by 500. One easier way can be that you divide, like you subtract 500 minus 57, where there is no link. So that is the only cases where there are no links. It will give the same answer, which is 0.88. So any doubt in this question? I think it is not. But even if you have some. So this is again very scoring question. So if you get this, it will. But you have to remember the formula. That's stuff. Okay. So moving forward. Yeah. Again, a rendered question that what is the commonness of S, comma C4? So they want to know that given Tokyo and concept 4, what is their commonness? So what we have to apply? You have to apply this formula. Well, W comma C given by summation of sum of all the concepts. So now what is LW comma C here? That is S comma C4. That is Tokyo, comma 50.
7 by 443.
Yeah. So again, we are doing this similar thing. So we are doing LW by C4 by sum of all of them. So 7 by 443. Any doubts in this question? So this is again a formulaic question. So yeah, if you apply the formula, it should be very easy. And there might be, yeah, I think there are more than 4 concepts or uh, variations, but more or less it will be. Any doubts for this question?
No.
Okay, the next question is information extraction can directly help in which of the following downstream tasks. So for this types of questions, so the idea is, so this is not directly available in the slides, but from the question itself, you have to understand. So you have to understand two things. One is what is information extraction, and second, what are the meaning of this task. So if you understand both of these things, so you can directly understand, like, or directly apply where this information extraction can help. Yeah, so information extraction is a task of finding structured information from unstructured or semi-structured text. So if you are given structured text or like unstructured text, for example, a story or article, you have to find out the structured information. And then you have been given 4 options in which you have to find out which one of these tasks can information extraction help, or help in the sense it can solve the task. So can it help in automating all knowledge base construction? So the knowledge base is a kind of like graph, a graph where there are different links to different things, and like the links are basically relations between those entities.
I think yes.
Okay, entity linking. So in entity linking, so only information extraction cannot help us directly because we need the knowledge base, some uh, already existing knowledge base as well. So only extracting the information is partial, like partially completing the entity link task. That is maybe the mention detection part, but we have to link it into the database as well. So that part is missing. So entity linking will not work. Neural machine translation, it is a completely separate task. It has nothing to do with information extraction. We have to translate the information. So we have to convert the information from one language to another. So that thing, so there is no work of information extractions there. And finally, question answering from documents. This is also a task where this information extraction can help. So if you are given a question, you find the answer to this question using some information extraction process. So both 1 and 4 will be the correct option. Here again, like the simple like understanding of both these things, like what does this task mean. So for this you can like, I guess it will better prepare for some common NLP tasks that are there, that are commonly done. That's sentiment analysis or hate speech detection or natural language inferencing. like just know the brief about this task and then try to understand what you have been taught in the class about information extraction or relation extraction, and apply this in this task. So if it is possible, then write yes. Otherwise, okay. Then we coming to the last question of the session. So what are some of the drawbacks? Yeah. Before that, is there any doubt in this question? So again, there is no like foolproof way to solve this question, because you need to know a lot of things ideally, but try to see if you can find some of the common NLP tasks that are there and apply whatever you've learned in the class. So that is the only uh, hint or guide. Okay. So what are some of the drawbacks of using hand-built regex patterns for relation extraction? So for relation extraction, sorry, what is relation extraction? First of all, that we want to establish the relation between two entities. For example, Nidal is the capital of India. So here, the capital is a relation between Nidali and India. So this is known as relation between two entities, and the extraction process of this is known as relation extraction. So now there are different ways to do this, and one of the ways is hand-built race patterns extraction. So now, so hand-built race patterns can be like if there are two capitals or one capital, one country, then uh, add this relation to this or something.
Two and three.
Not possible to extend to new patterns automatically. Okay. Can a costly to obtain a large set of such patterns? Okay. Why not four?
I didn't understand the sentence.
Yeah. So let us go one by one then. Any other answers? Okay. So the first option is low precision. So this cannot happen. Like because we are using hand-built regex patterns, so they must have. These are mostly done by experts of the linguistic society. So they have seen this patterns through different documents or corpus, and based on this observation, they are doing this. They are making this regex pattern. So they are always high precision because they may not have high recall. That is, they cannot maybe extract all the relations that are existing, but whichever they will extract, it will be more or less correct. So that is the first option, which is wrong. Not possible to extend to new patterns automatically. So since these hand-built regex patterns are fixed, so to extend it to new patterns that are emerging in the document, we need uh, again we have to observe the things, and then the experts can add another regex pattern to the current pattern, so that we can identify this new relation. Hence, this part is also not this is correct. So we cannot extend to new patterns automatically. And third is costly to obtain large set of such patterns because experts are limited and they may charge higher money. So to have more such experts, we will need more money, and that is costly. So although it is highly precise, but it is also very costly process and cannot utilize easily available text from large corpus. So the last part is that when we are doing such hand-built reduced patterns, we are not utilizing what unstructured text or semi-structured text is available. So if there is any automatic method or semi-supervised method that can utilize this text as well, so that will help in better understanding of the reduction instruction. But for hand-built reduced patterns, we are not utilizing this available text. So this is the fourth. So 2, 3, 4 are the correct options. These are the drawbacks of the hand-built regex patterns. So these patterns, as I told, that these are generally hand-built patterns which are written by linguistics and domain experts. Hence, they are costly to obtain, but generally have very high precision.
Can you explain relation extraction again once more?
Yeah, wait a Yeah, let me show an. Yeah, so for example, let us see this article. So this article is about like the flight price increase in Chicago. So they are saying that Chicago is citing high fuel prices, said that it has increased fares by $6. Then there are different entities that are highlighted, like American Airlines, unit of AMR, then Tim Wagner. So these are the different entities that are highlighted. Now let us see what are the relations that we can extract. So first is American Airlines and AMR. So American Airlines is a subsidiary or a subsidiary of AMR. So AMR is an entity, and American Airlines is one of the subsidiaries of this AMR. So that is shown by the unit, a unit of AMR. So a unit means subsidiary. So this is one relation that is existing between American Airlines and AMR. Then similarly, Tim Wagner is a spokesperson of the American Airlines. So he is an employee. There is another relation. So this we are doing manually. So say for example, United is a unit of UL. So United Airlines is a subsidiary of UL. This process of finding these relations. So once we have the entities, we want to find the relation between those entities. We want to understand what is the relation between American Airlines and AIM. So which is we have already with the entity linking process. So this process of finding the relation between those two is known as relation extraction.
Okay, thank you.
So I think you can get this in the slides in detail. Like there are different methods to it, like how to do patterns or even modern methods like neural networks. But the overall idea is to find this relations between it. Okay. Any more questions, doubts, anything?
Excuse me.
Yep. Yes.
In this distant supervised learning, is that the unsupervised learning same as that? Can you
No,
call that? No.
exactly.
Then
So
which one is unsupervised learning in relation extraction?
yeah, before moving on to relation instruction, so unsupervised learning is like let us understand the concept. So relation instruction is just a task, but unsupervised learning is a process where we do not have any notion of the label. So consider a classification task.
Ah,
So I am taking classification task because it is a supervised learning task, but it is considered for now that we want to solve it in unsupervised session. So in
okay.
unsupervised setting, we'll not have the labels like what are the classes. You have to find the you have to learn on your own what can be the labels and then assign. In supervised learning, you have the correct labels. So you can use those labels and add a training loop and try to add as a feedback. In distant supervision or weak supervision, you have some notion of the label. So you can have you have labels for um, like
Yeah,
very
but it is
crude.
done automatically through some
No,
automatic process.
which one?
There is no in the distant supervised learning.
Yeah,
The
yeah, all the
labels are
learning.
created automatically through some the
Yeah,
tools or
yeah,
maybe
that you
something.
can say. So you can. So for example, a very easy like for emotion identification, you can use the hashtags. For example, if the hashtag happy or sad is there, or the emoticons is there, the emoticons happy is there. So I can assign that as a happy post. So
Okay.
that thing that you are assigning is a weak supervision because there is no human intervention to add the level, but still you are getting some notion of it. So similarly here, so this is the three things that are different.
But can you please give me one example of unsupervised learning in this case? Like, so where do we use like?
Yeah, so unsupervised learning is mostly
Actually, I didn't find, or maybe I missed anything related to unsupervised learning in the slides, and also I went through the lectures. Uh, so I actually got confused with the distant supervised learning.
okay. So okay. So in unsupervised learning, actually they are saying is they mostly rely on handcrafted features. So that is the first method that we showed. Like, that is the RE based method.
That is the bootstrapping we are talking.
Okay.
No, there are three methods actually: bootstrapping, then supervised learning, then distant supervised learning. But there is also one question there in the assignment regarding unsupervised learning. But where or what is the scenario where it is used? Actually, I didn't find anything. That is why I have this doubt.
So unsupervised learning is essentially used in like so if you have a large text. So let's say you have a large text without any labels. Let's say entity code. In that case, you can use such like handcrafted features to understand the relations.
Handcrafted features. Achha. Handcrafted features.
Yeah. So I think MD1. The URE methods which rely either on handcrafted features or surface form. So they are not really relying on the labels or classification part, but they are mostly relying on the handcrafted features. So this paper can help you.
No, but where can we use? Like say in language translation.
Language translation, no, otherwise it will not work that way. But again, you see, like these are Language translation not work. So unsupervised learning is mostly utilized in let's say clustering. So there we are not using any labels, but uh, we are still trying to find some clusters which can denote some labels. Is one.
Yeah, that is a method.
Yeah. But for relation extraction particularly, they are saying the paper that I sent, they are saying it is mostly um, like doing something of a. So there is this extended topic modeling, REL LDA. So that is the extension of the LDA algorithm. Find the relations.
Yeah, machine learning techniques that will be used, but okay, I'll go through. Thank you very much. I'll go through to find out any application. It's a where appropriately it can be used.
Yeah.
Yeah, thank you very much.
Yeah. Okay. Okay. Any other doubts?
No, sir. I think we can.
Okay. Thank you all for joining.
Excuse me, sir. Yeah, I have a doubt.
Yeah. Please go ahead.
Sir, in assignment question, one of the question was like consider a data set with very low number of relations, all of which are very important. So for a relation extraction task on that data set, which of the following is most useful metric? Right?
Very less
So
relations.
yeah, so for relation extraction, which is the most useful metric? Precision, recall, accuracy, and F1 score.
Okay.
Right, but in lecture material we are only given the precision and recall information about only precision and recall and F1 score. I guess
And what
accuracy.
is the last one?
Accuracy.
Okay. So accuracy is simply, so these are like common metrics. So I don't think any, like even if the
So
course does not cover you guys.
specifically it is not mentioned that when to use which metric in what cases.
So think about, so when you are selecting a particular metric for a particular case, think about what is the most useful criteria. So here, what is the question? That text has very few relations, right?
Very low number of relations, all of which are very important.
All of which are very important. So your task here is that we find the relations and with high accuracy.
Okay, because they are important, so we need high accuracy, right?
Accuracy, I'm saying high. So that part is important. That you have to find that all of them are important. So if all of them are not important, you could have like selected very few of them like highly correctly. Like you can
Okay,
select very few of
so
them with.
we have to use the matrix which is giving all the important
Yeah.
ones, right?
So we have to select the matrix uh, which is helping us to get all the entities because all of them are important. So try to think which metric will be that. So we are not bothered about whether we get some false examples or not, but we want to get all the entities. So now try to think which of the options is correct.
So I think is it related to that confusion matrix,
Yes, it is
policy
related to the
matrix?
confusion. But you have to
Okay.
think. So for this kind of questions, the main aim is to what is important for you. So is it the importance is that whether you want well, whatever you select should be correct. Whether you want that part or
Okay.
whether you want something like highly accurate. So these things are different in notion, like different in the expectation of the task. So what is the metric that is required will depend on what is the expectation from the task. So try to
Right.
think.
So I guess we required true positive values only, right?
Yeah, we need true positives. Yes.
Okay. Okay. Thank you, sir.
Okay. Yeah. So I think we can close them. So as usual, the slides are there and the videos will be uploaded to the channel. I think you already know the channel link and all the things. And I have also added the paper link that I shared in the chat. You can go through that paper to understand about unsupervised relation extraction. Okay. Thank you all. Closing.
Thank you.
Thank
Okay, thank you, sir.
Thank you, sir.